And we're live with JavaScript Air. Hello, everyone. My name is Kent C. Dodds, and I'm your host for JavaScript Air, this live broadcast podcast all about JavaScript and the web platform. Today, we're going to be talking about JavaScript debugging, and we have a couple experts on the subject here with us, both on the node side and the client side, so it should be a spectacular episode. Before we get into it, I have a couple of announcements. First off, I just want to give a shout out to our sponsors. Egghead.io is our premier sponsor, and they have a huge library of bite-sized videos about web development and Node and React and all kinds of awesome JavaScript-related things. So check them out at egghead.io. Then we have Front-End Masters. They're an expert-led recorded workshop with courses on advanced JavaScript, asynchronous, and functional JS, as well as lots of other great courses on front-end topics. And then Track.js is a special sponsor today. They report bugs in your JavaScript before customers notice them. And with their telemetry timeline, you'll have the context you need to actually fix the bugs. Check them out and start tracking JavaScript errors today at trackjs.com. And Wallaby.js. Wallaby is an intelligent, super fast test runner with JavaScript, for JavaScript that continuously runs your tests. It reports code coverage and other results directly in your code editor immediately as you change your code. Check them out at wallabyjs.com. And CodeCove. CodeCove is coverage done right. Reduce technical debt by visualizing test performance and faster code review. CodeCove is highly integrated with GitHub and provides browser extensions. Learn more at codecove.io. And so we're really excited about those sponsors because they're allowing us to do some really cool things with the show, like transcriptions. And so you'll notice on the website we're starting to get transcriptions on the episodes, which should make consuming these shows a little bit easier. So really excited about that. Great. So other general announcements. Next week we are having a special show. This is the first time for this show. We're doing a live broadcast from a conference. So Forward.js, the Forward for Web Technology Summit, is going on next week, and several of the panelists and I will be there, and we'll do a live show at the conference. So join us next week. It's a special time. It's going to be 12 p.m. Pacific time, not 12 p.m. Central time. So it'll be a couple hours later. And yeah, but it will be on the same day. So let's go ahead and introduce everybody. For our panelists today, we have Brian Lensdorf.
Hi, how's it going?
And Getify.
Yo.
AKA Kyle Simpson. I don't know what he wants me to call him. I'll just call him both.
Getify is good. Getify is good.
Getify. All right, sweet. And then for our guests, we have Alex Liu.
Hey everyone, how's it going?
I'm not sure if I pronounced your name correctly. I didn't ask you before. Is that right?
No, you got it right. Yeah, perfect.
Awesome. And Yunnan Xiao. Oh shoot, I totally forgot how to pronounce your last name.
No, that was good. Hey everybody, I'm Yunnan.
Awesome. And Todd Gardner.
Hey everybody. Why didn't you ask if you pronounced my name right?
Did I pronounce your name right? All right. There be trolls on this show. So let's give our guests a chance to introduce themselves before we get into our subject. So Alex, do you want to go first? Just tell us about where you work, what you do, that kind of thing.
Sure. I'm Alex, and I'm currently at Netflix. I spent most of my life kind of in the front end, and recently, in the last couple of years, I've kind of moved exclusively over to Node land, so building a lot of tooling and microservices and other services that Netflix products may depend on internally. So it's been a wild and crazy ride so far, but also really fun.
Cool. Thanks, Alex. And Todd, why don't you go next?
I'm Todd. I'm a web developer, and I'm the president and co-founder of Track.js JavaScript Error Monitoring.
Sponsoring the show. Thanks, man.
You bet. You're doing great work.
Thank you. All right, and Yunnan?
Hey, I'm Yunnan. I'm at Netflix as well with Alex. We're working sort of on the same team. My career has really been in the infrastructure space. So previously I was at AWS and at Joyent, working on infrastructure as a service and cloud computing things, which has been a lot of fun. And presently at Netflix, we're building a sort of platform as a service style platform on top of Node and Docker. So it's also a lot of fun. But that's kind of what I do.
Awesome. Great. So I think a good kicker-off question for our JavaScript debugging show today is why do we need to learn about debugging? Can't I just write my code and pull it up in the browser, and if it works, right? So I'm good to go. So why is that not really a good solution for debugging JavaScript?
So I have never been, I guess, a superhero developer to the level that I can write code and it works the first time, beyond like a couple of hours of work. Eventually I will make a silly mistake, or I will not understand an API, or I will not understand what my customer wants, or any number of reasons. And so if this isn't a problem specific to JavaScript anyway, like every language will have bugs, every system you interact with. And so debugging is one of these skills that transcends all languages. And it really moves, like if you can understand the basic tenets of how do you isolate and reduce bugs out of your system, you can be effective in lots of different languages and lots of different environments. JavaScript has its own subset of problems within that. So I focus mainly on the client side. And so a lot of debugging in client-side JavaScript is in dealing out with differences in the environments that we're working with. Because we're delivering our application to run in so many different configurations that all have very subtle differences. Is it running on OS 10 or Windows? Is it Chrome or Firefox or IE or Safari or Android browser or Opera or Brave or any of these other things that all have their little things that are weird. They all treat their API just subtly different. And so dealing with those kind of complexities add on top of the normal just building a system complexities. And so it's inevitable that we're going to have bugs.
Yeah, I mean, I think that's a great answer. I just wanted to follow up with that, which is that in addition to just silly typing mistakes and syntax errors, sometimes there are classes of problems which are not immediately obvious, which is like my code compiles and it runs and it seems to do the right thing most of the time, and so this is especially prevalent on server-side programming where you may have classes of errors that only manifest themselves under certain conditions, right? Maybe I'm at scale or there's a particular set of inputs to the system. And that's where it's especially important to be able to capture state and debug that when the error happens, because especially say at Netflix here we have millions of subscribers all using the service, and maybe only say 1% of the subscribers have the same problem, or even 0.01%. That's still a lot of requests and a lot of issues, and that's definitely not the mainline path that's that's problematic or having an issue. And so it's really important to be able to debug your system end to end and be able to sort of capture state when errors occur to be able to figure out what happened. So you can think of that as sort of like you want a black box or a flight recorder to be able to capture state while your service is running, to then be able to pinpoint and debug and root cause an issue such that you don't hit that issue again.
Cool. So, Todd, one of the things that you mentioned was that it takes a certain set of skills to debug JavaScript. Could we talk about some of the skills that are necessary for debugging JavaScript code?
Well, I think what I was saying earlier is that first, debugging as regardless of the language is a skill set that people acquire over time. And generally, like, the more bugs you write, the better you get at debugging. So there's a huge benefit to writing a lot of bugs. Debugging in any language, I feel like the first and sometimes the most challenging step is isolation. And so it's figuring out how do you isolate the part of the code that's going wrong. Because as we build like large complex systems, like data could be shifting around. We could have like a couple of different state machines interacting. We could have a couple of different moving parts in any system of some large scale. And so how do we find what part of the system failed? And so to do that, I think you really need to understand both the environment you're playing in and what are the flows that happen through that, and then the system that you're building, and what are some good points in your code, in your application, that you could attach to, that you could either just set in breakpoints, or you could spit out information, or you could just start hijacking into certain parts of your system to narrow down what part of the system is going wrong. And so in JavaScript, because it's asynchronous, and because we have a lot of different potential entry points that our code could start in, understanding what are the major entry points into a client-side system that would be appropriate to hook into. And so understanding that callback mechanism, understanding how does something resolve and where does the data flow through the system. I think those are more JavaScript-specific skills to understand the asynchronous nature of the applications that we're working with.
I had a question. Actually, I'm going to have a bunch, but this is my first question. So can you describe for the audience what is the difference in strategy between, there's kind of two main approaches that I've seen in debugging. One is debugging while something is happening. That's more of the breakpoint style of debugging, like stop something, pause something, I want to see immediately right now, kind of like look around at my current scope, that sort of thing. The other style of debugging is to record a bunch of stuff and then look at it later. And that harkens back to that whole notion of console.log. Well, if I had a console.log on every single line of my program, I could see the entire flow and just look at a nice chat history. And while it is painful to create those console.log statements, it's actually sometimes easier to find a bug if you go that way than it is to sort of debug while something's happening. For example, I'll talk about this later, but I've been working on a game recently, and like the real-time nature of playing the game, if there's some bug like right in the middle of gameplay, it's incredibly difficult to have that stop in a breakpoint, because then you lose all the context of my interactions, like what I was clicking and what the screen was doing at that exact moment. So can you talk about broadly the strategy differences, how we know when is the best approach, is one always better than the other, that sort of thing?
Well, I think so. There's the two approaches that you mentioned. The first one, which is really around real-time debugging, attaching debuggers, pausing the process. That's really useful when you're in the software development lifecycle, right? You're iterating on code, you're testing it, and something's broken, you can attach a debugger. In production, that's generally not possible, right? You can't, in my earlier days, I tried to do that in production, and you pause the entire process of serving hundreds of customers, and you cause a production outage. And like the thing that you mentioned within a game as well, if you have lots of players that's hitting the servers, or someone that's playing the game, if you were to pause the process, it literally pauses the entire world, right? And so, to speak to the latter, I think logs are definitely really great. There's obviously this big debate around lots of places where it's not possible to log out every single state object that's within the process. That's what we like to do, is be able to say track state across the entire process for the lifetime of it. But it's generally speaking, that's a lot of data that you have to capture, and then all your hardware and operating systems doing at that point is furiously scrubbing the logs and writing to disk. And so one of the techniques that we've been using, and again, I think the operating system provides really great facility for this, is to be able to capture the application state by capturing the contents of its memory. So generally, this is in the form of like a core dump, for example. You can, generally speaking, on any operating system, capture a core dump while the process is running, and that will pause the process for some small amount of time, say like 2 to 5 seconds, while it quickly dumps the contents of memory to disk. And then the process will continue to run, and so let's say you have a bug or something is broken, you can restart the process, but then you can take this core dump, which is really, again, like your flight data recorder, right, that has all of the information about the process, all of the state objects and variables, and then inspect that offline somewhere else. And so that we found that to be really helpful when there's errors or bugs in our code. And so generally speaking, for production services, that's a much better approach, because you're not impacting customers, right? And so we find that to be really, really useful. And there's some great tools in JavaScript to let you do that. I mean, the Firefox Dev Tools let you upload a VA heap, which has all of your state variables. There's server-side tools like MDB V8, lets you do that for Node. And so generally, we found that to be really, really useful in terms of trying to debug an issue in production in real time.
So
I'd like to.
Go ahead, Todd.
I just wanted to add another facet to that because that's absolutely right on. But even just in the dev cycle, I've personally used both of the approaches, both of the the breakpoints, stopping interactions, and logging out, because even at dev time, I have been known to write some really, really terrible race conditions in my code over the years. And when I'm trying to debug this complex set of timing interactions, when I attach breakpoints to the code, I can make the bug go away simply by attaching breakpoints. And so it becomes very hard to troubleshoot what's going on when the act of debugging itself was manipulating with the times. And so to debug those sort of issues, I found it much more helpful to do the reporting style approach of just dumping out different state changes and the timing interactions and saying, hey, this callback started, this callback completed, and investigating it afterwards so that I can see how those subtle timing things are actually changing when the system really runs.
That's absolutely true, and I think that's a great approach for when you have timing issues. I think another really sort of something to consider is there's all kinds of sort of dynamic tracing frameworks that let you at runtime, in a safe manner, generally inspect and trace events within your source, your process. So like dtrace is a good example. Or something like perf events on Linux, or LTTNG. Any of those sort of real-time tracing frameworks let you can either set breakpoints within your code, but they're not exercised until you start the tracing framework, and that doesn't really interrupt your code. It just dumps out state. So think of it as like I can dynamically enable logging statements within my code only when I want them, but those are good tools to use in real time to be able to get information without having to pause your process.
Yeah, I was going to ask a question about that actually. So something that I've done, at least for client side, is I have a logging solution that just abstracts console.log and the console in general. And then I litter my code base with all this abstraction. And then in production, if I need to debug something, I can just flip the switch to turn this on, so that I can get all that information dumped out. And so there's really no performance hit when some of those things have calculations and whatever. So would that be another kind of approach that would be helpful for debugging production applications?
Yeah, I think absolutely. If you can dynamically change basically your logging level or the verbosity of your logging, that's definitely something really useful. We've also often thought about, there's lots of platforms that don't have dynamic tracing frameworks, right? And so we thought of, and this is kind of dangerous, but it's something that we thought of, which is you can build like an API or REPL into your process that lets you dynamically set those switches. Of course, now if you have, say, a bug in your logging statement itself, where it throws undefined as not a function, then you might accidentally blow up your process that way. But it's definitely a way of changing the verbosity of your logging when you're in process.
I agree, Kent. On the client side too, having the ability to capture those logs is incredibly important. The service that I build does that itself as well, where we capture all of the logs about how the system is running for these exact debugging purposes. So understanding how the users are interacting and how your system is working in real production environments is really important to actually debug an issue at the other side.
Yeah, and I think a lot of sort of large installations or companies do is that they have a logging framework that's deployed on the client, and then that streams data back to the service, and then later on you can sort of look through that data aggregated and sort of map that back to, say, maybe a CS call. Someone might call in and say, hey, I have an bad interaction, and we get the customer ID and then look that up in the stream of events. So that's definitely very helpful.
What other tools? Oh, sorry, Alex, go ahead.
Yeah, so I was just going to kind of add, sort of a different perspective to this, which is that, everything that we've talked about here is completely and totally valid and really useful. I think an interesting twist to this is kind of like my own experience from having moved from kind of like a purely front-end environment into, running, say, like a service and having to debug those services is the kind of, I think, the importance of the mindset and kind of how that has to shift a little bit in terms of debugging your programs and getting visibility into what they're doing. Because I think, as Yunnan sort of rightly mentioned, like, turns out that you can't just like go into a production service and put a debugger in there and stop taking traffic. And so I think a lot of the growing pains that we've seen from having JavaScript developers moving from front end to like the new front end back end is sort of this skill, and maybe more of a and obviously this can be learned and groomed over time, but like thinking, I think, critically about your code paths and where you should be doing logging. And so oftentimes it's like maybe even something as simple as saying like, hey, I've got this function that like might be doing something complicated. I should probably log like at certain parts throughout this process that like I've started some process or ended some process, and that way you want to be able to get sort of that holistic view from step one all the way to step n of, hey, here's all the things that have happened when I started this process, and that way it's much easier to say go back and sort of see like an audit of everything that's happened since you began that request. And yeah, that's something that we've certainly found to be super, super helpful.
Yeah, like I just want to add one last thing, sorry, which is that the sort of collection of metrics, that should be the thing that you think about when you are initially building the service or the client that you're thinking about, and not something that you sort of strap on at the end, right? If you begin your process with which are the metrics that I need to collect, because often while you're debugging, right, you often need to log these metrics out anyway. So if you needed them during your debugging and development process, then you probably need them when you're in production. So it's always good to think about these things before you start actually coding and trying to figure out like, what are these metrics that I need? What are the states that I need to log out beforehand?
Right on. I had a question actually about sort of like that. When you're in production, there are these differences, right? If something works on your machine, it might be your database that's different. It could be like the hardware it's running on and environment variables and things like that. Do you have like any tips or like a list of things that you go through in your head when you're trying to debug something that works on your local but not somewhere else?
Yeah, I think the most important thing is, well, one thing to keep track of is that obviously you're trying to make sure that you're replicating the same environment, right? And so that's often like maybe you're running a different kernel version or a different V8 version or a different version of Node, or something that's critical in Node is like maybe my build isn't even the same. My package.json hasn't changed, but because of somewhere, all of my packages have changed between deploying on my laptop and then out in the cloud, right? And so I think what's really important is making sure that you're using the same set of binaries and code that on your laptop that you're running prod. And I think tools like Docker really help with this, right? Because you're able to snapshot a particular build as a Docker image, and you know that will never change. And so then it's much easier to isolate. Okay, so now maybe the only thing that's different is the kernel version of Linux I'm running on, or something like that, right? And so really it's about trying to isolate everything, like what Todd was talking about earlier. You really want to be able to isolate each and every individual part of your components and be able to report state back from all those. So let's say like your process is you make a request and it's failing. You need to be able to make sure you have enough metrics around which part of that really complicated distributed system that you're using, right? Is it the client? Is it the server? Is it the database? Is it the load balancer that's sitting between the client and the server, right? Is it the region that I'm in? And so if you have insight into those metrics, then it's a lot easier to figure out where in that chain things are broken. And so that's sort of my recommendations on that topic. As an aside, I think it's just generally really hard to debug. It's much easier to write code than it is to debug it, because to debug something, you actually have to be able to understand everything about the system that you're debugging, because there's lots of classes of errors that don't come from the code that you're writing, but maybe from a misapplication of a particular API or a system call or something like that, right? So you also have to really be able to learn a lot and try to understand all the subsystems that you're using.
So one of the things that can really help with debugging large complex systems is having thinking about points where you can inject yourself in at different phases of execution and know how to work with it. So for example, like if you have a client-side app and a Node web service and a database on the back end, can you hook in at different places and guarantee, like, if you know that if there's some problem in the system and you don't even know where to start, well, all right, let's start looking at how is the client communicating with the service, and let's compare, before the code break and after the code break. Is it sending the same payload? Is it sending the same headers? Is it making the same request? And if it is, you can say, well, nothing really changed here, so let's look at the other side. And so now do the same thing. Can you put a separation between your web service and the data store? And can you make sure that it's making the same calls? Is it asking the same query? Did something change with it? And just using those strategies to first isolate what part of your architecture is experiencing the problem, and then even within that architecture, build hook points where you're like, did we, make the correct decision about what this request means? Did we produce the right output state? Did we format the correct query? Understanding where are the places in your architecture, in your system, that you can attach these hook points easily to quickly isolate where in the system you're having problems, can really help make debugging less of a chore if you build your systems in such a way to facilitate these sort of patterns.
So I had maybe a little bit of a pushback on that, because so far it seems like the perspective being advocated for is smarter developers, smarter debugging. And I kind of call BS on that, because I feel like we're putting too much on the developer to already understand their problems and not enough on expecting the tool to figure it out and help me. So I will say contextually, I think people probably think of me as knowing a decent amount about JavaScript, but I think I am really terrible, honestly, at debugging. I feel like I'm in like 2006 in terms of my skill set around debugging, and I open up the developer tools and I look at the profiling tab and I look at the watches and stuff like that. Like, I know what that stuff is, but really effectively using it has not been a skill, even over 17 years of development, not a skill that I feel like has just automatically come. So I've sort of tried to refine my skill at developing better, so maybe I have a little less bugs. But what I would really like is for a tool, for example, I'm playing along in an application or doing something. If I see something wrong, I want to be able to point at my screen, touch my screen, and say, that was a bug. And have the system start telling me some contextual information about that exact moment, and maybe the stuff that happened in the leading seconds right up to it, and guide me to where the problem is, instead of me having to know, gee, I know exactly what kind of code was running then, and go find all the places for the breakpoints and stuff like that. Because honestly, I think that's one of the reasons why we spend so much time debugging, is because I don't think the tools are anywhere near what they ought to be to help us identify. So just wanted to see if anybody had thoughts on that.
I mean, that's a good point. I think what Todd and I, Todd, correct me if I'm wrong, but we're really advocating for is being able to get observability into the various processes inside your stack, right? So like the first thing that sort of generally like my approach to debugging is if something's broken, right? Like I don't know what it is, but I'm not getting an expected output or result from my system, right? Whether that's my client or my service or my database or anything in between. But before you can sort of make any assumptions or guesses about the problem, you need to be able to get data first, right? To be able to sort of, because if you don't have the data, then you're just guessing, and if you guess, then you generally, it's like closing your eyes and throwing a dart at a dartboard. Like you're probably not going to hit the thing that you want. And so I think step number one is making sure that you have access to all the metrics and state and data, or as much as possible, that relates to that particular interaction that you've had with the system. And then once you have that data, then I think, to your point, Kyle, about better tooling, I think once you've got that data, then it should be then possible to have tooling that helps you collate that data, aggregate it, right, refine it to give you as much context about that interaction that you've had as possible that closely relates to the pathologies that you've seen, right? So I think maybe the steps are really generate the data, make sure that your application, when you're developing, is generating data that you want, hook that into some sort of system that lets a tool then be able to inspect that data and give you contextual information about that topology to see.
So I think developer tools are actually pretty good at what you just said, but they assume that somebody already has a sufficient level of expertise on how to use that tool. I look at the Chrome developer tools, for example, and I'm like, oh my God, if I had a PhD in this stuff, I'm sure I could like rule the world with the kind of information that I have here. But in all of my attempts to like read tutorials, and certainly all of my brute force attempts to do my own code debugging, I feel like I am literally barely scratching the surface when I use these tools. So I don't think it's actually that the tools need to be more powerful. I think it's that the tools need to be less powerful and more dumbed down, more like, hey, you told us that a problem just happened. Here's the last 1,000 functions that got called. Here's what their inputs and outputs were, and let you sort of, you know, sift through that information instead of me having to have the foreknowledge to have the profiler on and then even know what the hell to do with that information.
So I believe that so I've definitely been in that situation where like I'm trying to debug something and I'm just getting too much information and like I don't even know where to begin. But what I think is a better approach to debugging is that debugging starts when you first start writing code in the system. Like debugging isn't just a thing of when you run into a problem. So the tooling gets better if I can actually attach it to my system in such a way that I can get good information from it. Because if you've built your system without any places to listen, then Chrome and these other great tools for listening to your application can just dump you tons and tons and tons of data, and it doesn't mean anything because you haven't built your system in a way that like certain parts of it mean something. So let me like throw an example. So sorry, I just lost my example.
So here's a good example from us, which is right. Like sometimes we'll get a customer service call that says like, "Hey, I went to this site and it blew up," right? And obviously you can imagine that with sort of the number of backend microservices we've got in the database and all the data that we have, you know, gigabytes or terabytes of logs and logging data that flows through the system, right? And to Todd's point, like the key is to be able to find and correlate that context with all this data that you have. And we've built systems where I can take a request ID from a particular customer's event and be able to then trace through the entire system of logs and get only context information about that particular request. And because the request ID is unique, then it gives us this, you know, like to Kyle's point, if someone just presented me with all the databases that contain data about all of our user events, just like Kyle, I think I would be overwhelmed and think this is ridiculous. But the key is to be able to build tooling on top that lets you differentiate and group state around specifics in certain contexts. And in our case, that's like a request ID. So tools like that are really helpful.
Yeah, I think in general this is just a really hard problem, and the tools are still getting better and easier. Like, you know, you just think back, even console logs in Internet Explorer 8 were not easy. And so, yeah, I think that things are definitely getting better. The time is flying by, and I want to get into something that's a little more practical for people. Well, all of this has been practical, but like very applicable for everybody watching or listening. And that is, I want to ask for the tools that you use to debug regularly and some of your favorite features from those tools. So, for example, I am a huge fan of the Chrome Dev Tools, and obviously, like breakpoints are something that I use all the time. But there's also this little checkbox in the Dev Tools that you can check that says async, and so it'll give you the call stack even if things are being executed asynchronously. And so you can step back in the call stack and you can look at the order of things that are happening even in an asynchronous scenario. So that's one of my favorite features of the Chrome Dev Tools. And so why don't we talk about some of the different tools that we use to debug our code. I'm actually personally really interested to hear some of the tools used to debug Node, because that's something I know very little about. So yeah, let's take it away.
Sure. I can talk a little bit about the Node side. So Node's different because it runs on the server. You generally have more than one tenant that's on it. And you can't really use the Chrome Dev Tools really. Like I mean, there's the Node debugger and there's a Chrome front end for it, and that generally works pretty well for sort of like the software development lifecycle. You know, I made some changes. I want to see see where the error comes from. I want to set a few breakpoints, and so that's generally sort of what everyone uses. No matter the runtime, if you're in Java, you'd use the Java debugger and likewise. But I think in production, what we found really handy is something that I described earlier on in the podcast, which is around, I've got a problem with my process. I don't really know what. I just know that, hey, I got a 500, or it's maybe, let's talk about something that's really sort of everybody has a problem with, which is memory leaks, right? I have a node process that's leaking memory. How do I go about debugging this stuff? So generally what we do is there's this really great tooling called MDB V8, which is a post-mortem debugger. So what that does is it lets you take a core dump, whether you generate that sort of a Lumos operating system or Linux, load it into this debugger and be able to inspect every single JavaScript object, closure, function, and all the V8 native objects interactively in a debugger. And that's really helpful because you're literally taking a snapshot of your node process, right, at any given point in time, without really interrupting the process too much. The process can continue to run, and then you can then load this into MDB, and using the plugin called MDB V8, it translates all of the V8 objects into all the JavaScript objects. It lets you see all the JavaScript objects in native JavaScript. So I can print out all the functions, see all the objects, and so for memory leaks, this is really helpful because I can list all of the objects and see which objects are leaking, because it sort of aggregates them for me. I'm able to find different objects based on their properties. I get access to the current stack, the stack of the process when the core dump was generated. And I'm able to walk through all the stack frames and get state information about all the function arguments on the stack. So basically, everything that you can think of that you wanted to know about your node process, as long as you've got the core dump, you can see it with MDB V8. And that's really, really helpful on the server side, especially when you're out in prod and you can't really attach a debugger because that means pausing the process, or you want to sort of, my process does some weird behavior, I want to capture that state. That's a tool that's really, really helpful.
So on the client, go for it.
Sorry. Yeah, I just wanted to add a quick corollary to that, which is, this came up in a conversation recently with me and Josh Klulo over at Joyent, and there was this interesting idea about like how we could potentially carry that concept of like having a core dump over to the browser as well. So effectively, today there's this big problem where like if you have errors or exceptions that are thrown in your browser, they kind of just disappear, right? Like they live on your user's machine, but there's no way for you to know about them unless you've built like this whole pipeline to be able to, pipe all this information back up to, your own internal services where you can then, inspect at a later point in time. What I would really love to see is, and obviously this is like something we'll need to work with the browser vendors for, is to have this kind of first-class support for being able to say like, hey, when an exception has been thrown and it's not handled and something gets dumped to console error or what have you, that we could sort of capture the state and maybe do like a quote-unquote like a mini core dump of the state of your browser JavaScript and then be able to send that back up, right? Because I think that's a big problem today, which is that all this stuff just disappears and it's hard to reproduce, and like what were the specific things in that scenario that caused this issue. So it's really hard. I would really love to see something like this happen for the front end.
I agree. I think that's awesome when that happens on the front end, which is why we built Track.js, which does all of that.
Bravo.
So I was going to talk about the client side because Chrome Dev Tools, I agree, is awesome. And like so many people have shifted to it from all of the other tools over the past couple of years. And the async stack traces, the Kent that you brought up, is amazing. And it does provide you a ton of really great tools. But the harder problem I feel in client-side debugging is that too many times we write to Chrome, and then like our stuff doesn't work when people hit it with other browsers. And so we become really familiar with the Chrome Dev Tools, and then there's a subtle Firefox bug, and now we have to figure out, not that the Firefox Dev Tools are bad, it's just there's a different like ideology that they took as they built them out, and so you don't understand how they work. And then the same thing with Edge, and then the same thing with Safari. And then even scarier, what if you have to debug like an IE9 problem? And so now you have to push back and try and do that. And so this was actually one of the core reasons why we actually built Track.js, which was this client-side monitoring tool, so that we could capture this really good debug information about like what were the console messages, what was the user clicking on, what was the contents of AJAX calls that happened beforehand, and be able to apply these to browsers that we were kind of scared to work with their dev tools on. So mobile is a great example, or IE8, IE9, those sort of things. And so I think in a lot of cases you can use production monitoring tools like Track.js to do dev time debugging in these environments that you're like a little bit less comfortable in the in-browser debugging tools that already exist. I think that's a really powerful use case.
I think also as a pro tip, as like Track.js is very cool. I have used it. But in addition, I think that it's really important for us to spend a little bit of time familiarizing ourselves with the dev tools for the environments that we're building products for. I think that's our responsibility as web developers. So what are some of the other features of different tools like that people at home listening can jump on their laptop and play around with that you all use regularly?
So one of the things that I've been a huge fan of, we were talking about logging earlier and logging out your contexts. There's a module called Vair that we use extensively in Node land, and basically what that does is allow you to create chained errors. So typically you might call some API and then you get an error in the callback, and then what we can do is say use Vair to create a new error using that existing error that was passed back to us. So what we can do is sort of start to effectively build like a really long, rich, and contextual history of all the code paths that some error is traveling through. And so it's really, really nice because then once it gets back up to something, you might often say just have a bunch of callbacks or a bunch of promises that are basically just returning an error up that chain. And then once it finally gets to an error handler, you can say, oh, I've got an error object. Let me just log it. And Bunyan, which is the streaming JSON logger that we use as well, knows how to work with these errors. And so once you log it, you actually get this awesome stack trace, which is just maybe 5, 10, whatever n errors deep that actually have stack traces and they have messages. And so without even having to say grep your code base or look through the actual code itself, you can actually see right there in the logs here are all the code paths that we traveled through that caused this 500 error page to get served. And so that, I think, has been really, really valuable for us.
One of the most valuable debugging tools that I use on a client side, and it has nothing to do with the JavaScript itself, but just a good proxy. So Fiddler on Windows or Charles on OS X, just to be able to see the actual data exchanges happening with the server I'm interacting with. Not the filtered ones, not the recreated ones that the browser thinks it should have made if it wasn't caching. The actual thing that went over the wire as it was formatted. It's one of the first things I install on any new dev build. Yeah.
Cool. I think we actually do need to start wrapping up the show. It's gone by fast, but we have a lot of questions on Twitter, so hopefully we can get through these really quick and then get to our tips and picks and wrap up the show. So for the first question that we'll address here, it's from Mark Lozano, and he asks, and yeah, I wish that Lynn were here because she would be able to answer this a little bit better maybe, but he asks, has Firefox Dev Tools caught up or moved past Chrome Dev Debugging Tools, and is CDT working on those gaps? I'm not sure what CDT is, but if anybody else knows.
Chrome Developer Tools.
Oh, that makes sense. 140 characters. So does anybody know about Firefox Dev Tools?
I only have biased personal opinion, and I don't know if that's what was being asked.
From what, if you listened to our show a couple weeks ago, we know that they're at least using modern technologies in the DevTools, which is whatever. It's great. But I have heard that the tools are improving.
I think what was said earlier is important to re-highlight, that they do actually have, in some respects, different philosophies about what context mentally a developer comes to a problem with. So I obviously, as I said in that other episode, I have 4-year-old knowledge of that team, but I know back then that the goal of the team was to build tools that were solving things that developers couldn't really solve with developer tools and other browsers. So their goal at the time, at least, was not to be feature comparative, exactly the same as Chrome tools, but rather to fill in other sorts of gaps and use cases. They had all kinds of interesting things. So, I know, for example, Firefox Developer Tools has like an actual command line environment where you can use command line commands to script what's happening in the browser, to actually control the developer tools, go through debugging programmatically step by step, stuff like that. So those are things that aren't in Chrome, and they're very different, and they have a different philosophy in Firefox. So I do recommend that all developers have a really good working knowledge, better than I have, of both Chrome and Firefox. And shout out to Edge. They have fantastic tools too. So don't just look at Chrome.
So the next question, I'm sorry to our questioners, we're not going to be able to get to all of these, so I'm skipping some. I apologize. But the next question is from Nick, and the question is, has any new types of issues been introduced with ES 2015 to be considered in the debugging process? So one example that I can think of is like arrow functions might make things a little bit more difficult to debug if you don't understand the semantics of that feature.
I don't know.
I think you're muted there. Yeah, sorry. Yunnan is trying to talk.
While he's working on his audio, is he back?
No. I'm back.
There you go. You're back.
Yeah, so I think in particular arrow functions, how to politely put this, it lets you really easily declare anonymous functions, right? And that's really great. Like, it's syntactic sugar, and it makes everyone's lives easier. But when you're trying to debug, say, on a server or anywhere else where you captured all the state and you want to look through your functions, they show up as anonymous and look all the same. And that makes it incredibly hard to debug, right? Because then you can't just disambiguate between all of your anonymous functions. So I would say, like, use them sparingly. Probably don't use them at all if you're on the server in node land, because at some point you'll have a bug or an issue and you want to be able to debug it. And if you can't see the names of these functions that you've declared, you won't have any context or any state into what caused the issue. So that's one of the biggest things, I think, in ES 2015, that it's one of those gotchas. Like, it's really nice, but at the same time, be judicious when you use it and think about the context that you'll be in when that code's being executed.
I've noticed that if you're using Babel to compile your code, and you assign an anonymous function to a variable, it'll actually name the function what you've assigned the variable to, which is kind of interesting.
Oh yeah, that's
awesome. Like
I don't know about that.
I mean, it's Babel though. It's not actually
not,
Harmony.
if you're on Node and U8 and you're using arrow functions, they're just anonymous, and then you're pretty much hosed on the server.
So let me jump in here and just clarify for those listening on that specific thing. I happen to know why Babel is doing that is because ES6, ES 2015 actually does have a feature called function name inference, which is a set of heuristic rules for how the JavaScript engine is supposed to guess what name you want for an otherwise anonymous function. And it doesn't cover all cases. So, for example, if you're passing it in as a callback to another function, there's no inference being made. But if you're assigning it to a property or to a variable name, it infers that you want to name it the same thing. So that's why you're seeing Babel put that name in there, is because they're emulating the ES 2015 name inferencing. So in all fairness, yes, anonymous functions are bad for debugging, and arrow functions lead to that, but ES 2015 does have a built-in correction for at least some of those cases.
Nice. Nice.
Just those callbacks. So I actually just had a wild idea of a Babel plugin that would, if you couldn't infer the name of a function, just put the line number as the name of the function, like function at line number whatever. Yeah, it's wild ideas. Okay, so next question from Vic. It says, I want to start debugging my Node applications today. What tools can I use? Is there an up-to-date guide out there? I think we've talked about some tools, but we haven't specifically called out any guides. Maybe we can link to some guides. Does anybody have anything to say about that?
Yeah, if you so for the core DOM sort of postmortem debugging topics that I talked about earlier, if I put that in the show notes. So if there's a very well written documentation by the author, Dave Pacheco, who walks you through how to generate a core DOM, how to use MDBVA, how to look at any of the objects. So that's all the postmortem stuff. I know that all that is very, very well documented. And also, I think I've given a couple of talks around how you debug things with MDBV8, so feel free to look those up. And so that's for MDB. I think in terms of just general debugging in Node, I think there's tons of documentation out there on how to start up Node in debug mode and attach a debugger. Though we probably should have that on like nodejs.org or something to just really help users. So that might be a pull request that the community can send. But that documentation should be readily available.
If you could add that to our, sorry, if you could add that to our show notes, that would be great. That way people can find it later. Thanks.
Cool. Yeah, I was just going to add, like, as far as debuggers go, I know Node Inspector. Well, there's the ever popular console log and console warns, but Node Inspector itself has, been sort of resurrected from beyond the graveyard, and so I know that's back in play. But from our team, at least from some of the folks working on our website, Visual Studio apparently has been the go-to debugger these days. So this is VS Code, which is actually the new editor that Microsoft released. Apparently the debugger there is fantastic. I've heard lots of great things about it. Though caveat, I haven't actually used it myself yet.
Great. I feel so bad. Let's see. I really don't think that we can get to these questions in time. So if any of you want to check out the hashtag JSR question and just answer those on Twitter later, that would be awesome. But we're going to wrap things up. So Brian Lunsdorf, I think you need to go first on your tips and picks since you have a hard stop.
Yeah. Right on. Well, really, just in general, I think patterns like Redux and event streaming and free monads, things that send labeled actions might lead to a much easier to debug app eventually. We've done this in the past where we have a database of events, and that's like our audit, and you can recreate the state of the app at any given time. So these front-end architecture ideas are pretty interesting to me. So I linked to a few. I guess the Elm architecture kind of takes the idea of a central store and events. So there's this time troubling debugger that they have that you can check out, and then free monad approach to interpreting your AST. Instead of running it, you can generate a graph. Brian McKenna made that. And then I just had some tips on working with pure data structures, because they force you to handle errors, as well as push all your errors up to the calling code, which is really interesting and nice. I think that's all I want to talk about. So. Cool.
Goodify, you can go next.
Okay, several quick things. Since we've been talking about developer tools, one of my new favorite ones that I just discovered in the last week or two working on this game is Chrome has a super experimental thing, but I already found it majorly useful. They have CPU throttling, so it literally synthetically slows down the CPU available to your JavaScript, so you can start to see how that affects things like the frame rate and your JavaScript execution on slower devices. That was an amazing find, so check out CPU throttling. You have to enable all these experimental things, but it's cool to use once you get it. Couple of non-coding but code-related quick tips. I would say always open source your code early. Don't wait until it's good enough for others, because then you've waited too long. Open source is not really about about collaboration improvement, not really about promotion of already finished code. The second tip is to start with libraries and frameworks as you rapidly develop and evolve and explore a project. But as it matures, I implore you to try to build in time for refactoring to reduce and remove those pieces. You don't need them permanently, and the best code is code that's exactly what's needed, no more, no less. A couple of quick picks. An article just came out today, fantastic, on a new tool, experimental, becoming the web platform called Create Image Bitmap. So Arrow Twist has a blog post about that, and also he mentions the new request idle callback. Both of those are pretty cool for handling images off thread. Another two tips are very self-serving. Our picks are very self-serving. I put out a tutorial with Chris Coyer of CSS Tricks called Chris and Getify Make a Game, and we put out part one of that. That tutorial video is out. It's like 90 minutes long, where we start on the first steps of a bare bones Canvas game. And secondly, I open sourced the code for this game I keep talking about. The game is called Cloud Sweeper, and I put that code out yesterday, so people are welcome to come and take a look at that, and if anybody wants to help, that'd be awesome. So that's it for me.
Cool. It's a fun game. So we just got a nice tour of the Netflix office, so if anybody wants to watch while Kyle is doing his tips and picks, Alex and Yunnan both had to move rooms, I think.
Yeah, we got kicked out of we got ejected from the conference we were in.
Nice. Cool. So I'll go ahead and go next, and then we'll let our guest go last. So for me, just a tip, teach. I think the pinnacle way to learn is by teaching, and so force yourself to, or put yourself in situations where you have to teach. So I just committed to give a training workshop at work next week on a subject that I know a little bit about, but I want to know more about, and so I'm forcing myself to learn it so that I can teach it, and I think that's a really good strategy for learning things. I also have two picks. What's new in Webpack 2? This is a link to a secret gist. I hope Sokra is okay with that. But it's gotten a lot of popularity on Twitter and stuff. And then debugging JavaScript. This is a link to the Chrome Dev Tools, some of the features in the Dev Tools. So recommend you check that out. Why don't we go with Alex next? I think you're muted, Alex.
There we go. I know how to use technology. So yeah, as far as links go, really just a couple of things I talked about, like creating those rich errors. So we've got like Vair and Restify errors, which is actually what we use in our REST framework, and that's built on top of Vair. Lets you create custom constructors for your error types, and then those work the same way as Vair ones, which let you sort of chain these errors. So totally great. You can use them with Bunyan for logging. So as far as tips goes, I think this is tightly tied with some of the great discussions we had around debugging today, which is really, as you're building out your applications, to think critically about errors and your error handling paths. I think too often, we get really, really excited and passionate. We're like, hey, let's build out this great thing, and happy paths are good, and then we go and try to shove in the error handling later, and that typically ends up leading to a lot of bugs. And yeah, I think that's kind of my top tip of the day.
Great. Todd, why don't you go next?
Awesome. So I got a couple of picks. First off, there's this thing I helped write, called Track.js, which generates the whole stack core dumps from client-side browsers. And I've said it like 3 times today, but you should really go check it out because it's awesome. Second, I spend a lot of time thinking about debugging, and so I did a talk last year on JavaScript forensics, where I kind of walked through a sample application and did live debugging of this silly application that I built, and showed you some common error cases and how to use Chrome tools to find and fix those problems. And so I'll put a link in the picks on where to find that. I gave that talk at a conference called NDC Oslo, which is an amazing conference, and I'm just going to give them a shout out. I'm probably going to be back at NDC Oslo and run this, help them run their after party, which we call PubConf. And PubConf is we basically rent out a bar, We get a bunch of really cool speakers to do Ignite-style talks, and the whole thing is generally free. So if you are fancy that sort of thing and want to come to Oslo in June, where the sun never goes down, you totally should, because it's awesome. And then finally, a non-tech related pick at all is I've been really enjoying the work of Ken Follett lately. He wrote a couple of books a really long time ago that I finally got around to reading, called Pillars of the Earth and a World Without End, which is kind of like this historical fiction stuff. Real places and events, but fictional characters set in them. But it's really good. That's all I got.
Cool. I was hoping that you were going to pick NotePadConf, but...
NotePadConf was a funny joke last year, but I think it might be dead.
That's disappointing.
But maybe we should drop a link to NotePadConf anyway, because the website for NotePadConf is still hilarious.
Yeah, absolutely. Thank you. All right, Yunnan?
Yeah, sure. So I dropped some links into how you debug Node in production. I gave a talk on how we do that. Links to the documentation around all of the tools that we use. I guess the number one tip that I would give when it comes to debugging is really just apply the scientific method. You'd be surprised at sort of how many problems you're able to solve just by applying that method, right? Which is like, get data, form a hypothesis. Does your hypothesis fit the data? If it doesn't, repeat the process, kind of thing. So that's one of the tips I would give. Use frameworks that give you observability into your app. Right? That's another big tip. It doesn't matter what you use. I put some links to Debugging and VAsync, which are the former is a JSON streaming logging library, and the latter is a observable async library for JavaScript. And some picks, something not related is BoJack Horseman. Excellent show, my favorite show on Netflix. I think we've got a free trial somewhere, so check that out. And something that we're actively working on, which is Reactive Socket, which is a bidirectional reactive framing protocol that gives you that you can use to apply back pressure, and that's really critical to our new sort of data access re-architecture that we're actively working on Netflix. But Reactive Socket is open source. We're actively working on it. In particular, a colleague of mine, Michael Paulson, and myself are working on the JavaScript implementation. So check that out. All the time, which is "Wish You Were Here" by Pink Floyd. Congrats.
Okay, great. So that's our show. Let me just give a couple of closing announcements here, and then we'll say goodbye. So if you have suggestions for the show for guests or future topics, this show is actually a result of a suggestion. Just go to suggest.javascriptair.com. And also, if you had feedback for the show, we'd love to hear your feedback. And so go to feedback.javascriptair.com. And this is new. We're pretty excited about this. Go to javascriptair.com/deals, and there are some discounts for conferences, and I'll continue to put different discounts that are exclusive to our listeners and viewers. So yeah, javascriptair.com/deals. And then also, I'm starting to collect email addresses for a mailing list that I'm going to do after the show's done and everything is up on iTunes and everything. I'll send an email with the show notes and links to the show, so you can get those right in your inbox. So go to jsair.io/email to sign up for that, or you can get the link on javascriptair.com. And again, next week is Forward for Web Technology Summit, and we're going to be a couple hours later. We'll be live at the conference, talking with some awesome people about what they're doing at the conference and different JavaScript-related topics. So check that out next week. And yeah, with that, I think we're good to go. So thanks everybody for coming. Really appreciate the conversation, and we'll see you all next week. Goodbye.